Okay, good morning class. Right, so at this point you're busy with analytical geometry. You have written another class test on trigonometry, which we will mark in our next lesson. You guys had homework. The homework was on exercise 11.4. Okay, and then you had to do the revision exercise as well. Not so? Yes or no? No. Is a revision exercise a handy assignment? No. Okay. What's wrong with me? Did I say it's not? Okay. You must use it for you. Okay. I don't want to give you too much work to do. Okay. So I know you guys are pressed because the June exams around the corner, so I'm backing off a little bit. Okay. I'm considerate for those of you who think I'm not. Okay. The girl is making as if she's crying. Are you okay? You're not okay. Why? What do you want to go to? Maths lit? No. What are you crying about? You just sad. The maths making you sad? No. Right, let's look at question 4 quickly. We are told that P, Q, R and S are 4 points on the Cartesian plane. Determine whether or not PQ is perpendicular to RS. If PQ was perpendicular to RS, what do we know? The product of the two gradients is? Negative 1. So if we can prove that the product of the two gradients is negative 1, they are perpendicular. And the contrary is also true. If the product of the two gradients is not negative 1, then it's not perpendicular. Okay. So what we're going to do is we're going to find the gradient of PQ. Right, so if you can make this x1, y1, x2, y2. So it's going to be y2 minus y1 over x2 minus x1. So it's going to be negative 1 minus 3 over 1 minus 1. So hang on. This is going to be an undefined gradient here. Not so? Which means to say it's parallel to the y-axis, yes. Okay, so if this works out to be 0, then it would be parallel to your x-axis. Then it would be perpendicular, not so? So let's check. So we got the gradient of RS. Again, y2 minus y1 over x2 minus x1. So it's going to be 2 minus 2 over 2 minus 5, 0 over minus 3, which is 0. So are they perpendicular? This is the special case, not so. So we say since the gradient, since PQ is parallel to the y-axis and the gradient of the line RS is parallel to the x-axis. Therefore, RS is perpendicular to PQ. This is that special case. Not so. Then, looking at number 5. Okay, we didn't do a calculation on collinear, no? No, so I'm going to do all 3 of these, okay? So, looking at A, we are sure that these sets of points are collinear. So 5A, so we're going to, let's look at that being A, B and C for argument's sake. So we're going to work out the gradient of AB and the gradient of BC. If the gradients are equal, what does that mean to say? They're collinear. If they're not equal, they're not collinear. What does collinear mean? So it lies on the same line. Okay. So if I go y2 minus y1 over x2 minus x1, it's simply negative 4 minus minus 6 over 2 minus minus 2. So that's going to give you negative. It's positive 2 over 2, which is half. Not so? Yes. Gradient of BC. We do the same. Negative 3 minus minus 4 over 4 minus 2. Or you could have said minus 4 minus minus 3 and 2 minus 4. Gives you the same answer. That gives you 1 over 2. Are they the same? Yes. So we conclude. Since the the gradient of AB is equal to the gradient of BC, which is equal to half. Therefore, A, B, and C are collinear. Okay, you guys understand? Alright, let's look at B. Let's look at B. Same story. So we call that A, B, and C again. So the gradient of AB, change in y over change in x. y2 minus y1 over x2 minus x1. Or if you want to say yb minus ya over xb minus xa. However, if you say ya minus yb, it will be over xa minus xb. Okay. So let's do our thing. It's going to be 1 minus 5 over 1 minus minus 5, which is minus 4 over 6, which is negative 2 over 3. We work out then the gradient of BC. So it's going to be negative 1 minus 1 over 4 minus 1, which is negative 2 over 3. Are they the same? Yes. So we say since the gradient of AB is equal to the gradient of BC, which is equal to negative 2 over 3. Therefore, A, B, and C are collinear. Why? Because of the gradients are the same. Okay. And C is the same. Is C also collinear? Yes. Okay. People, if that was not equal, then you just conclude, therefore, the gradients are not the same. If the gradients are not, let me say, since the gradient is not the same, you pull a line through the equal sign, therefore points are not collinear. Is C collinear? No. Okay, so let's do that one. So I thought these were going to all be. But let's go with C. So the gradient of A, B, again we got A, B, C. So it's going to be y2 minus y1 over x2 minus. What do you notice? Is that my handwriting being ugly? What else do you notice? Besides Kumalu sleeping as well. What else do we notice? Because I'm writing down the formula every time. It's obvious. Why am I writing the formula down all the time? There we go. So 0 minus minus 6 over minus 2 minus minus 5. It's going to be 6 over 3, which is 2. Not so. Gradient of BC. Or I could have said AC. If BC doesn't work, not giving you the same gradient, then AC won't give you the same gradient either. You understand? So BC is going to be 2 minus 0 over negative 1 minus minus 2. So it will be 2 over 1, which is the same. You see it not the same? It takes, okay. So put the line there and change. These are the same. So how do we conclude? Since the gradient of AB is equal to the gradient of BC, which is equal to 2. Therefore, A, B, and C are collinear points. Okay? Or points. Will you guys understand? Alright, let's carry on with our lives. Right, in question 6 we are told, calculate the value of x in each case if A, B, C and D are points given. If A, B is parallel to CD. People, if points are parallel, what do we know? Gradients are equal. Alright. So, for A, I need to work out the gradient of AB, and we need to work out the gradient of CD. Okay, how do we work out AB? y2 minus y1 over x2 minus x1. For AB, it's going to be, this is x1, y1, x2, y2. Not so. So it's going to be 3 minus 4 over minus 2 minus 1. Or if you had said 4 minus 3, you would then say 1 minus minus 2. Same answer. So that's going to give you negative 1 over negative 3, which is the third. Not so. Now you work out the gradient of CD. So the gradient of CD is changing y over changing x. Same Mickey Mouse did. So it's going to be 4 minus 1 over x minus minus 4. Not so. It's going to be 3 over x plus 4. Right. Now what do we say? Since AB, gradient of A, since AB is parallel to CD, therefore the gradient of AB must be equal to the gradient of CD. Why? Because the lines are parallel. So it's going to then be a third is equal to the gradient of BC, which is 3 over x plus 4. So what do I do now? Cross multiply. Is x plus 4 equals 9. So x is equal to? Okay. So if the lines are parallel, x is equal to 5. And let's look at the other side. If you're looking at B, if AB is perpendicular to CD, then what? Product of two gradients is minus 1. So if you got the gradient of AB times the gradient of CD must be minus 1. Okay. What's the gradient of AB? A third times gradient of CD? 3 over x plus 4. That was the gradient of CD there. Okay? Equals negative 1. So I divide by a third first. So that cancels. So it's 3 over x plus 4 equals negative 3. You all agree with that? Now what do we do? Cross multiply. So that's going to give us 3 is equal to negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Now we solve for x. So 3x is equal to negative 15. X is equal to negative 12. Is that correct? Yes. Right. C. B, C and D are collinear. What does collinear mean? Lies on the same line. If points are collinear, what do we know? Gradients are equal. Not so. So let's take this off. So I need to work out the gradient of CB. Do I have the gradient of CB? No. And you must work out the gradient of BD. Do I have BD? No. But I got CD. So I'll go just with CD instead. Can you see that? Otherwise I must work out the gradient of BC and I must work out the gradient of BD. You understand? If you had done it like that, no problem. You should get the same answer anyway. But I'm just a bit lazy, as all mathematics people are, no? Is that right? Yeah. Yes, you have to find shortcuts and all of those things. No? That's normal. Right, so BC, this here. So we say the gradient of BC equals 1 minus 4 over minus 4 minus 1, which is negative 3 over negative 5, which is 3 over 5. Not so? Whilst the gradient of CD is this here. Alright. So if points are collinear, gradients are equal. See, you see here we are told that they are collinear. So the gradients are equal. If they ask us to prove that points are collinear, we then prove that the gradients are equal. Make sense? No? Same like in geometry. Right. Euclidean I'm talking about now. No? So the gradient of BC is equal to the gradient of CD. So it's going to be 3 over 5 is equal to 3 over x plus 4. So we've got the fraction on either side of the equal sign. So what do? Cross multiply. So it's going to be 3x plus 12 is equal to 15. Bring that over. 3x is equal to 3. So x is equal to 1. Is that correct? Right. Okay. Let's carry on. Express y in terms of x if the given points A, B and C are collinear. If points are collinear, what do we know? What do we know? Gradients are equal. So we got A, B, C. So that means to say the gradient of AB is equal to the gradient of BC. Not so. So the gradient of AB is y2 minus y1 over x2 minus x1. So it's going to be 4 minus 2 over 1 minus 3. So it's going to be 2 over 4, which is half. The gradient of BC is going to be y minus 4 over x minus 1. You all agree with that? So we say, since points are collinear, therefore the gradient of AB is equal to the gradient of BC. No? That is collinear. You don't have to write it in. No? Or I could have gone with AC. No? I went with BC. Doesn't matter. Okay? So we say the gradients are equal. So a half is equal to y minus 4 over x minus 1. Cross multiply. 2 times y is 2y. 2 times negative 4, negative 8. Equals x minus 1. What do they want? They want y in terms of x. So in other words, I must make y the subject of the formula. Can you see that? That they get over. So 2y is equal to x minus plus 7 divided by 2. Y is equal to a half x plus 7 over 2. Or x plus 7 all divided by 2. Both is acceptable. Okay. What's wrong, Leanne? That you're pulling your eyes like that? You making me scared? So what I think, okay? Alright, can I carry on? Right, I'm going to do one more. Which one do you want me to do? C. Okay. So if these points are collinear, then the gradient of AB is equal to the gradient of BC. Okay, so AB is going to be y minus 7 over x minus 3. Not so. And the other one is going to be the gradient of BC. It would have been easier if I had gone with AC. Okay, because I made the call already, so let's do it like that. So it's going to be minus 5 minus y over 9 minus x. Alright, so if points are collinear, what do we know? Gradients are equal. So the gradient of AB is equal to the gradient of BC. Let's see what's going to happen here. So it's going to be y minus 7 over x plus 3 is equal to minus 5 minus y over 9 minus x. So if you cross multiply there, it's going to give me y minus 7 times 9 minus x is equal to minus 5 minus y times x plus 3. So it's going to give you 9y minus xy minus 63 plus 7x. Okay, it's equal to negative 5x minus 15 minus xy minus 3y. But what's going to happen now is that minus xy would cancel with minus xy. Not so. So I bring that over the equal sign. So what I'm going to do is I'm going to keep the y's on one side. So it's going to be 9y plus 3y is equal to x is on the other side, which is negative 5x. X is in the numbers. Minus 36 becomes plus 63, sorry. Minus 7x. So that's going to give you 12y minus 12x. What's minus 50 plus 63? So it will be positive. 50 is 48. Just check there. Right? Divided by 12. So y is equal to negative x plus 4. The other way is definitely easier. Not so. So it would be the same as we did in A. But like I said, I made that call there, so just work with it. But you're supposed to have spot that it would have been easier the other way. Because there are less variables to work. You understand? That's what makes it a bit easier. But as long as you're not making an error, then as long as you're not making a mathematical error, breaching mathematical rules, then you're going to get the same answer all the time. That's a nice part about maths. Okay, is that you can do whatever makes sense to you at the time. As long as you're not making a mistake in your maths, you're going to get the same answer. And that's why maths is so easy. No? Because there's many ways of answering the same thing. People, question 8. It says determine the coordinates of D, the fourth vertex of the parallelogram, ABCD, if. Any issues here? No? We did quite a few of this, no? Right? Let me show you another way. I think that's the last question, no? Yeah, let me show you something else quickly. Another way of working out this D, no? Let's go with, we can use the lengths. Because if everybody can write this down, because we're going to try it in B afterwards. Now you look at the order here. It is A, B, C, D, in that order. So you got A, B, C, D. Okay, write this down, people. So if this is A, B, C, and D is your unknown value, no? Which is X and Y. So your A value is -1 and 1. Your B value is 3 and 5. Your C value is 1 and 0. And D is what you want to find, no? Okay, now you see this is a parallelogram. What's the properties of a parallelogram? There are 4. Opposite sides are equal. That is the rule I'm going to use here. Okay? What's the other one? Opposite angles are equal. The other one? The angles bisect each other. Not so. And that's the one we normally use here to find D normally. Not so. Then we must work out that center point. And then we work in reverse and we get the D point. Not so. That's the one method, but sorry. So I'm going to go to the next page. We're not there yet. We can't even do grade 10 trigonometry properly yet, no? People, trig is something that you need to sit with. You know that jealous boyfriend kind of the guy? No? You know about him? No? He doesn't want you to spend time with no other friends of yours. Don't you know what people like it? Yes. No? Trigonometry is like that. You either spend time with it or he's going to get upset with you. No? He's going to divorce you. What? You split up, whatever. No? Now you must listen. There's no way out of it. You must spend time. Okay? But this is the story here, people. You see, moving from A to B. If I move along this line, am I moving along the X or the Y axis? The X axis. You see that boy now X now, you see? Why does that do that? Yes. You see tricks on it. You just want to be within our lives, no? Right, let's go here. The board needs to be aligned. So, right. So, if we're moving along your X, not so. So, -1 to 3 is how many units? No, moving from -1 to 3. How can it be 2? 4, man. Right, so then what would this length be? 4. Can you see that? Now, if I move from 3 to -1, I'm moving in that direction, -4 units. Not so? So, if I move 4 units in that direction, then what's the X going to be? -3. Can you see that? Just move along here. If I move along here, am I affecting my x or my y? Your y. So from 5 to 0 is how many units? 5, no? 5. So if I move down, you're subtracting 5. That's where your negative is coming. So what is 1 minus 5? Negative 4, and there's your D. Easy. Now do the other one as well quickly. Alright. And I would like to actually do it. So here goes A, B, C, D. And this always work for parallelogram, rhombus, square, rectangle. So you got A, which is negative 2 and negative 1. B, which is 1 and 6. C, 3 and 4. And D, X and Y. If I move along here, am I affecting my X or my Y? Your X. So from negative 2 to 1 is how many units? 3. So that is 3. But 3 in that direction I'm subtracting. Not so. So 3 minus 3? 0. Let's go here. Moving along here, affecting my X or my Y? Your Y. So 6 to 4. How many units? 2. So there goes 2. Not so. So what is minus 1? You go in this direction, you're subtracting, not so. How do I know if I look here? So I'm moving in that direction 2 units. So minus 1, minus 2. Okay? Easy. Discuss the merit of the method you use compared to the other possible. That's the other possible method that I just did. Okay? Which is much easier. Not so? Right, people, that's the story for now. This basically brings us to the end of analytical geometry. On Monday we're starting functions, graphs. Okay. People enjoy your weekend and the rest of the day. Good morning, class.